So hello everyone, this is Devangan Ghosh this side, and today I will be introducing you to my newly made project, which is also my UROP project. And the topic of my project is synthetic data generation using generative AI in a agentic AI workflow. So basically, in this project, I have tried to implement generative generative AI, uh, generative AI to generate synthetic data in a agentic AI loop where I have gone through few research papers and few real world application of synthetic data, which I will not be covering in this video because you can get a ton of videos in whole YouTube talking about synthetic data and where we need it. Basically, my problem statement was till date there is no platform where we can directly automate the process of generating synthetic data. So I thought, why not give it a try and try to make uh, workflow, agentic workflow, because right now LangChain, Langgraph are very popular in our AIML community, which can easily use many tools. You can use many tools to create a workflow where you can automate many tasks, and it can be done in few matter of minutes if you know how to code that language. So basically, I have used Langgraph to automate the synthetic data generation and evaluation, where I have used the feedback mechanism and loop for evaluating my synthetic data with the real data I got, so that I can get a DIR score, which is disparate impact ratio score, which I will be talking in a few while explaining the actual workflow of the architecture. Right now, you can see the workflow right here. Now let me take you to the screen and let me show you how the architecture actually looks, which will help you understand more about my project.
Hopefully you can see over here the architecture of the project I made. Basically over here the name of the project is SynEthica, which is I think a pretty cool name by the way. And here as you can see we passed the real data over here. So here we are basically using only tabular data right now. Later we will be scaling it to audio, image or video part if we continue this project. Right now this is the real data which we are passing, which have basically bias and all, and this goes to the AIF 360, which is a module or library you can say made by uh, other people, other developers. This is basically is module is used for your bias checking, and after this will be generating you the baseline report. Now the baseline report contains the bias report of the real data we have right over here. Now this report then is sent to the generative code. So this is basically this whole area is the generative code, and in the generative code we have two agents working, which is the DPLLM, which is the differential privacy large language model agent, which handles our privacy and budget. So basically this acts as the brain. So what it does, it will be getting the baseline report and it will be getting the essence of the raw data. It will be taking, we will be passing through the queries over here, and we will right now we are using the Gemini API for it, Gemini LLM, because either the LLM which we are about to use are available in the Hugging Face, but they are either very pricey or it takes a lot of time to actually get the permission to use the APIs. So right now it goes here, Gemini will see the strategy and the prompt, and then it will act as a brain and it will give the strategy how to generate the data in order to make a successful synthetic data. Then this whole strategy will be saved into a JSON file where we will have the strategy text, and that will be going to this SDV models. The SDV model is synthetic data vault model, which is a library of model where we have tabular variational autoencoders or CTGAN. CTGAN is basically tabular generative adversarial network, I guess, pretty hard to pronounce. So that strategy it will be, this will be using, this is basically, if this is the brain, this SDV model is basically the workhorse of this whole project. This will be generating the main synthetic data using the strategy Gemini gave. Now in here we will be taking some parts of the, like if we have 1000 rows of data, of real data. It will be taking like 300 or 200 of the real data. It will be augmenting it. It will be like flatten it, and it will shuffle it randomly, and then it will add another 200 to 500 data, whatever the strategy made by Gemini, and that will be generated as the new data. For example, now let us take that 600 rows of new data is generated with the synthetic data. Now this synthetic data will be passed to the QA metric agent, basically quality assurance agent, and what this will do, basically this and this are same, are in the same files, but right now because I have made this project, this architecture few months ago, so it's not shown over here. So basically it will be taking the synthetic data and it will be taking the real data. It will compare them side by side, and it will check whether the synthetic data have bias or not, or is it does it pass the metrics, bias metrics of DIR, which I told is disparate impact ratio. Disparate impact ratio is the mathematical calculation of the fact that how much bias your or how much fair your data generated is. So right here, this DIR is actually used by AIF 360. Now AIF 360 in the baseline report, it will give that like 0.5 is the DIR or bias of the real data, so it is very less. So we can set it like 0.8 as the threshold DIR rate. So unless and until the DIR rate generated of the generated data, synthetic data, is not 0.8 or more than 0.8, it cannot come out of the loop. If it does have the DIR rate of more than 0.8 or 0.8, it will be coming out, and we will be getting the synthetic data in loop 1 itself. If it doesn't, this will fail, and this will again go to the synthetic code, and then the DPLLM, the Gemini LLM will be again making a strategy, and this will again go to SDV models, and it will again make this synthetic data, add new rows, shuffle the data again. For let's take for the second loop, it became from 600 to 1000 rows of data, and it went again, and this time when it checks, the DIR rate comes like 0.9, and which is higher than 0.8, so it will be coming as output. Unless and until the DIR rate is above 0.8, it won't come out of the loop, and this whole thing is wrapped up in LangChain. So I hopefully you understand the architecture. Now I will be coming to the code and show you the live execution. So this is the live execution which I'm gonna show you right now. Let's because I have used a virtual environment, so let's activate the virtual environment. Yes. And activate. Hopefully this activates. Okay, this activated, and then we will be running the main.py file, which is the entry point of our agentic workflow through LangChain. Main.py, and let's see how it calculates. So you can see that we have the raw data right over here. Now the raw data I took not from any Kaggle dataset, because it will be making the things very complex, and the SDV model will be taking too much of workload, which my laptop won't be supporting. So I just generated it using Python script itself. And now from this, as we can see that the input agent, the DIR agent, has given the DIR rate is 0.48. So this basically means, as you can see, like the data loaded is, you can see over here, the data loaded shape is 1000 by 3, which means 1000 rows we have. If you go actually down here, you can see we have exactly 1000 rows and 3 columns, 3 attributes. So the shape is 1003, and the DIR rate is 0.8, which means we have pretty much half, 50% more, 52% bias, which is not actually good. So it will be going into loop 1, and we can see that the strategy is decided basically using the Gemini API, which is the code is written in the the reasoning node. So you can see the strategy is over here. Yeah, we have the strategy over here. We're passing the DIR and all the important essence of the data through the prompt to just give a context or reference to Gemini that whatever we are trying to solve and what he needs to give the response as. We can see in the loop world we have strategy is decided, and it has told the plan is 400 rows of data. We have to boost 100 rows of data, and then the generator agent, which is basically this. This is the SDV part where we are using tabular variation autoencoder. We can see SDV, and we are seeing the metadata over here, and this is baseline sampling and boost sampling, the fix, and basically we are making the synthetic data right from this part. And as you can see, it is completed. Now this is the QA agent where it will be assuring that how much DIR rate and overall quality is. So you can see that the overall average quality is almost 80%. The DIR is not so good, but it has increased from 0.48 to 0.53, which is good because it's increasing. Now because the threshold is 0.8, or I don't remember what I gave here, but right now this is going to loop 2, because unless and until it meets the threshold it won't be leaving the loop. So okay, we have some error, but you can see the essence, the DIR again came to be 0.67 right here, and the quality is 77%. So DIR has increased again.
So I hope guys you have seen the live execution, though it didn't execute completely, where I thought like it would go for like loop 3 or loop 4 till it gets like the DIR of 0.8. But the Gemini LLM, Gemini API fails often if you do run it on a free tier. So that is why I think this failed. But I hope I'll show you a live execution one more time later in the video if I'm posting this later. But that is the essence of the main project which I want to give you. Also, as you can see that one of the things you might have noticed that whenever we are trying to increase the fairness or reduce the bias, basically we need the DIR to be more, and more DIR means the fairness in the synthetic data is better. uh, you have seen that the quality degrades. As the fairness increases, the DIR increases, the quality of the data decreases. Now you will be thinking, why does this happen? So there are a few research paper you can search, or I will be mentioning in the YouTube description. You can check it out. So this basically happens because in real life scenario, if you take a real life scenario, things are not very ideal. We do have bias, and in synthetic data, we are trying to reduce the bias. Now, when we are trying to reduce the bias, we cannot achieve that ideal state, that ideal data we cannot achieve. Just like humans are biased, so the data also is biased. The quality of the data degrades basically when you are trying to increase the fairness. When you are trying to take the fairness to an ideal position, the quality will degrade. So you can learn more of that from some research papers. I will do mention the PPT link of my documentation which I made for this UROP project in 7th semester. Down below, you can check it out. And if you are trying to make such a project, I will also try to fine tune this project, like make this project better, and then I'll be mentioning it in my other social media handles or down below. I'll be updating after a few months, uh, not few months, like few days, because my exams are coming soon. So I hope you like the video, and that is all about today. And let's meet you in another project, another cool stuff. Till then, good night.